for solving quadratic equations, we have seen three methods. The method number one was factorizing, number two was completing square, and number three was using quadratic formula. Okay, we have seen what is discriminant of a quadratic equation. Discriminant is b square minus 4ac, and depending on value of this discriminant, it will decide whether you are going to get real and distinct roots, or real and equal roots, or then no real roots. Correct. So let us start working on discriminant now. Okay, I have written one quadratic equation here. Here k is a constant. Okay, k is a constant. Let us try and solve this, right? And what I'm going to do is I'll take this 1 on the left hand side, so I get a proper quadratic equation. So kx square plus k plus 3 into x minus 1 is equal to 0. Okay, now the objective of this quadratic equation is you have to find k such that you get, number one, equal roots, I would say real and distinct roots, and number three would be no real roots. We have to find the values of k for which you satisfy these three conditions. Okay, so now let us try and expand this, and let us test this part, b square minus 4ac. So we know that if delta is greater than 0, real and distinct roots, delta equal to 0, equal roots, and delta less than 0, no real roots. So we will test these three conditions, and we will get the values of k for that. Okay, so first of all, let us find what is your delta. So my delta is equal to b square minus 4ac. Now here what is my b? My b is k plus 3. So I'll write k plus 3 square minus 4 into my a is equal to k and c is equal to minus 1, right? So this becomes k square plus 6k plus 9 plus 4k. Now this 4k plus 6k, that becomes 10k. So it would be k square plus 10k plus 9. This is my delta. So let me check for equal roots. So for equal roots, delta has to be 0. So I am writing number 1 here. I am taking number 1. For equal roots, delta equal to 0, therefore k square plus 10k plus 9 equal to 0. I am going to use factorization method. So my 9 is equal to 9 multiplied by 1. So k square plus 9k plus k plus 9 equal to 0. So k into k plus 9 plus k plus 9 equal to 0. So that is k plus 9 into k plus 1 equal to 0. Correct? So if the roots are real and equal, okay, this condition has to be satisfied. So my k has to be, so k plus 9 equal to 0 or k plus 1 equal to 0. K plus 9 equal to 0 or k plus 1 is equal to 0. So what does it mean? It means that k is equal to minus 9 or k is equal to minus 1. So if I put k equal to minus 9 or k equal to minus 1, my roots are going to be real and equal. What about real and distinct? So for real and distinct, my k has to be equal to, my delta has to be greater than 0, right? So number 2, delta greater than 0. So that means my k plus 9 multiplied by k plus 1 should be greater than 0. Now when will this condition be satisfied? Now here just imagine k is greater than, so now here k plus 9 should be greater than 0 and k plus 1 also should be greater than 0. So k plus 9 greater than 0 and k plus 1 greater than 0. This is one condition. Or if k plus 9 and k plus 1, if both are negative, then also the product will be positive greater than 0, isn't it? So I'll write or k plus 9 less than 0 and k plus 1 less than 0, right? Now what does it mean? So k greater than minus 9, okay, and k greater than minus 1, okay, both these conditions have to be true. Now if you see on the number line, if you check on the number line, k greater than minus 9, okay, k greater than minus 9 can be minus 8, minus 7, but then another condition is k greater than minus 1, correct? So if k is greater than minus 1, it is definitely going to be greater than minus 9. So the only condition that I can, so instead of writing two things here, I can write only k is greater than minus 1. Okay, now let's go to the other condition. So k should be less than minus 9 and k should be less than minus 1, right? K is less than minus 9, k is less than minus 1. But imagine something less than minus 1. Minus 2 is less than minus 1. But then is it is it okay with this then? K, if k is less than minus 9, then it will be definitely less than minus 1, correct? So I choose this condition, correct? So for real and distinct roots, I take this condition and this condition. So my k should be greater than minus 1 or k should be less than minus 9. This is the condition for this second result, real and distinct. So if you have these values, okay, then your roots will be real and distinct, right? Now the third condition, no real roots. Now for no real roots, what do you want? My delta should be less than 0. So in that case, if delta is less than 0, maybe I'll make quick changes in this. So now see here, I want delta less than 0, correct? So k plus 9 into k plus 1 less than 0, correct? So my k plus 9 should be greater than 0 and k plus 1 should be less than 0. Now just note that one of them is positive and one of them is negative, correct? And now again, or if this is less than 0 and this is greater than 0, so one of them is positive and the other one is negative, okay, and here it is and, or this and this. So my k is greater than minus 9 and k is less than minus 1. K is greater than minus 9, k is less than minus 1. What about the second one? Or k is less than minus 9 and k is greater than minus 1. Now how do you do this? How do you get the actual values? K has to be greater than minus 9, k has to be less than minus 1, k less than minus 9, k greater than minus 1. Okay, so now here you have to figure out, right? You have to figure out on the number line, what are the possible values that k can take, so that you get your discriminant less than 0 and you get no real roots. So you can plot that on number line, right? So that's what that's what was working with discriminant. You have to write your a and b and c, then figure out what is the discriminant there, okay, and then depending on the values of discriminant you can figure out whether your equation is going to have real values, real and distinct roots, or real and equal roots, or you are not going to have any real roots. Maybe you can get imaginary roots, right? Thank you.